Yesterday, would you agree that as we began this concept of function composition that we were plugging into two functions, but we were always plugging into the inside function first, and then we worked to the outside function. And we were always using numbers, so our answers came out to be numbers, and that's nice. But today, we're not going to have numbers. We're just going to be plugging in, well, we're going to be plugging in equations. We're going to be plugging equations into equations. So our answers are not going to be numbers. And that's still nice, but it's a little harder. So let's focus in. Take your pamphlet from yesterday. We're actually going to flip to page 5. And on page 5, there is a chart to help us continue to understand more of this function composition. Now, some of this is notation. That's often how math goes. So similar to yesterday, we see the little circle notation that still stands for f of g of x. We can rewrite that as f of g of x using more parentheses without the circle. But perhaps that might help you to realize that the g of x that's on the inside, well, that actually equals something. Yeah, that equals, well, according to the other page over here, it equals x minus 5. So that should mean that I can take x minus 5, there we go, I can take x minus 5 and substitute that in the place where we had this g. So now it's like I'm being asked to do f of x minus 5. Well, wait a minute. That should mean that I should be able to substitute x minus 5 into the f function. I'm going to flip over here one more time. Here's your f function. And if I was going to substitute into my f function, I would substitute right here. But what am I going to substitute? That's right, I'm going to substitute x minus 5. So let's be careful on this first one. I'm plugging x minus 5 into the f function. But that means I'm going to be plugging it in where that letter x was. So I'm going to end up with 3, the substitution of x minus 5, but I still have the minus 5. Now, I'll tell you, this minus 5 at the end, that's what's often forgotten. People understand how to substitute. They substitute correctly x minus 5, but then somehow we leave out the rest of the equation. But if you substitute it correctly, you end up with a little distributive property. You end up with some simplifying, and that ultimately gives us 3x minus 20, which I want you to understand is really the final answer back from the beginning of this f of g of x. How about h of g of x? I could go backwards. I could write that with the little circle notation. Kind of looks silly because it says hog, but it's h of g of x. Now, specifically, g of x is on the inside, and whatever's on the inside is where we start. So that should mean that I can replace that g of x on the inside with what g of x equals. And g of x equals x minus 5. So I replace g of x with x minus 5. But now I have to do h of x minus 5. What does that mean? Well, it means wherever you see x in the h equation, we're going to substitute, notice it's 2 places, we're going to substitute x minus 5. So that, it's getting wonky on me here, that means that I'm going to have something substituted and squared. I'm also going to take negative 5 times whatever it is I'm substituting. But of course, I'm substituting x minus 5. Now, I want you to notice here that I have very carefully used parentheses with my substitution. Yes, whatever you substitute, the place that you substitute always needs parentheses to very nicely organize and sort of group each of the substitutions. X minus 5 squared. Remember, that's the same as x minus 5 times x minus 5, which is going to be the same as x squared minus 5x minus 5x, which is minus 10x, plus 25. But I still have negative 5 to distribute over here. And if I distribute that carefully, I get negative 5x plus 25. Now, I have some like terms that I can sort of simplify, like negative 10x and negative 5x. That's going to be negative 15x, and 25 and 25. So that's going to be 50. X squared minus 15x plus 50. I told you the answers aren't going to be numbers today, but we're still plugging functions into functions. Just got to be a little bit more careful. We've got more expressions, more algebra. F of x. F of x. What does this really mean? Well, it means you're plugging f into the f function. It's like you're plugging f into the f function. Let's write it out. My f function from the other page is 3x minus 5. Now we're going to put 3x minus 5 into the f function. The f function says that I get 3 times whatever I'm going to substitute. Don't forget your minus 5. And what am I going to substitute? 3x minus 5. So we plugged 3x minus 5 into 3x minus 5. Do a little distributive property. Simplify some more, and you get 9x minus 20. Interesting. Now it's your turn. See if you guys can do the two requested compositions. As I always say, make sure you're trying this. Don't just copy it. Too easy to copy. You got to push pause. You got to try to set up these problems. Yes, I'm going to go over them. Here we go. G of f of x on the inside. F of x is the same as 3x minus 5. That means I'm going to substitute 3x minus 5 into the g function. Now be careful, the g function's kind of simple. The only place to substitute is right there. So I'm going to substitute right there. I'm going to make sure I don't lose track of the rest of the equation. The rest of the equation is this minus 5. But nonetheless, I'm putting 3x minus 5 in there. Those parentheses don't really matter this time, but it does simplify to be 3x minus 10. H of f could be written as h of f of x. Kind of say it the same way, but you just write it differently. F's on the inside, so that's what's going to get replaced first. F is 3x minus 5. I'm going to plug that into the h equation. Yep, that h equation, it's got two places where you got x. Why don't you put some parentheses so you have a space to fill in? You're filling in the first spot, it's going to get squared. You're filling in the second spot, it's going to be multiplied by negative 5. 3x minus 5 squared. Same as 3x minus 5, 3x minus 5. Very carefully, that's 9x squared. It's negative 15x. It's another negative 15x, and it's positive 25. Of course, those negative 15s are really going to become a negative 30x. How about over here? Distribute -5. -5 gives you -15, gives you +25. If you look at all of your numbers and your terms, you should be able to add together the negative x's, so that's -45x. The 25's also add together, and you get 50. 9x squared minus 45x plus 50. Ready for some more fun? Function composition is this idea of always plugging a function into a function. It turns out that you can use function composition to see if two functions are inverses. Yeah, suddenly there's a little connection to inverses. And here's the thing. Inverse functions, they kind of cancel each other out. So if f is the inverse of g, or g is the inverse of f, it doesn't really matter which way you do it, then if you do function composition, if you plug them into each other, it should all cancel out to just be x. That is, if they're inverses of each other. So we get a problem where we say show that they're inverses. Well, what that's really asking you to do is to check out the function composition, to do f of g of x, which is the same as doing f of x plus 7 over 2, which is the same as plugging x plus 7 over 2 in for x. Now when I plug it in, I'm going to have a nice parenthesis ready. I still have my 2 and I still have my minus 7, but here comes the x plus 2 over 2. Now I know it's a fraction, but look what happens. Look what happens. The multiply and divide by 2 cancel out. So I'm just left with x plus 7. I still have my minus 7, which is perfectly going to cancel out with the existing 7, and I get x. That means that these are inverses. I did function composition, and they canceled to be x. You try. You try. And just so you can try it the other way, see what happens if you do f of g. See what happens if f is on the inside. You're going to plug 3x minus 6. You're going to plug that into the g function, right? What's going on with my little arrow here? It's moving. Plug that into the g function. Get a parenthesis ready, but don't lose your 1/3 and your plus 2. Distribute your 1/3. 1/3 times 3 is just x. 1/3 times minus 6, it's kind of like dividing by 3, so you're going to get minus 2. It's kind of like 6 divided by 3. You get 2. You get cancellation, and that's how this is supposed to work. You end up with just x. Now, are all functions inverses of each other? No. But if they are inverses of each other, it's going to cancel to be x. So I guess that means if they're not inverses of each other, they're not going to cancel to be x. One last function composition concept. Everybody's favorite application. Now this indeed is a little trickier. Just a heads up that I will require you to do one of these problems one day for a grade. So let's see if we can figure it out today. And it's not that bad. It's just something we got to try. It's a little different, but it's going to involve two functions, and we're going to show you how we can put them together, which of course is composition. Sale at the music store. Drum kits are 20% off. And if you're a preferred customer, you get an additional 15% off. Not sure what it means to be preferred. I don't know if that means the owner likes you. It probably means that you paid some kind of little membership fee. So 20% off and another 15% off. Now, we're going to want to write a function composition to represent the final cost. We're going to do a function composition, get the final costs. and we're going to do a little something with $248. But the first thing we need to do is individually write the equations. So what do we got? 20% off. The first one's 20% off. Let's call that a discount. We use the letter D. So the discount equation, D of X. Now, if something's 20% off, that means you're going to pay 80%. You're going to pay 80% of X, of the cost. Again, 20% off is an 80% cost. How about the 15% off? Let's call that P for preferred. The preferred equation. Now, if I'm going to pay 15%, if I'm going to get 15% off, that means I'm going to pay 85% of the original cost. Hold on, if you were trying to figure out the final answer already, notice I'm doing the individual answers. So, what's the first discount? That's right, it's the D. It's the D. What's the second discount? It's the P. P of D. P of D of X. P of D of X. That's your discount equation, or that's your function composition of the discount equation. So I should be plugging D, right? I should be plugging D into P. I should be plugging 0.8 into the 85X. Are you keeping track of the numbers here? We're gonna still have an 85, but I've got a little space ready, got a little parenthesis ready. I'm gonna plug in my D equation. Now, I wanna make sure I didn't do this too fast. What you do first always goes on the inside, right? So we put the D equation on the inside. What goes second always goes on the outside. So I see my 0.80 on the inside times 85. That's actually something you want to calculate now. And when I calculate it, you take 0.85 times 0.8 and you get 0.68x. 0.68x. What is that? That's your final equation. That's your final discount equation. And again, it's technically P of D. So I can use that discount equation, P of D, to figure out how much a drum kit's going to cost. It's $248. Basically, just take 0.68 times 248. It's like I'm getting both discounts at the same time. And when I get both discounts at the same time, I'm going to pay 68% of the original cost. 68% of 248, 168. Not bad. 168. Saved nearly $80. So interesting. Seeing hopefully how function composition can be used when there's like a double discount. Let's do a problem that's kind of similar. It has to do with discounts and such. What do we got here? We got a jewelry store. I guess Raymond owns the store, so he's got to pay 10% on each piece of jewelry that's in his store for like insurance. So yeah, that kind of like raises the cost. And then he wants to make some money, so he prices the item at 150% of his cost. Again, this is going to end up being how much does he have to sell these items for. So we're going to write a composition. We're going to write a composition for the price, for the final price. If something originally cost him C. Let's see if we can sort of piece this together. Now remember, X would be the cost of the jewelry. In other words, it's like his cost. His cost. How much does he have to buy the jewelry for? And then he has to raise the price by 10%. Now, if you raise something by 10%, you have to pay 1.10 of what you bought it for. So if I raise it by 10%, I got to add that one. and then he sells it at 150%. So it's 150% of x. I got two equations. What we got to do is put them together. Because when you put them together, you get both of the upcharges at the same time. So what do we do first? We do the insurance first. So as you can see, that goes on the inside. That means we're going to have S of I. S of I. I should have fixed the colors here, but I is the 1.1. And then I'm going to plug this 1.1 into my S equation. Plug 1.1 into the S equation. Now the S equation has a 1.5. Put a little parentheses so you got a spot for your 1.1x. And we end up with, when you multiply these together, 1.5 times 1.1 comes out to be 165. Basically 165% upcharge. He has to charge the people 65% more if he wants to cover these costs and make some money. So that's your combination equation. That's both of them together. We can use that to answer a fun question. If he's selling something for $12.50, that means that that's the final cost of the item. But that's going to equal my composition equation. Now, obviously, I'm just going to divide both sides by 165, but you realize that that's going to give us the original cost of the item, kind of the wholesale cost, if you will. That means he purchased that jewelry for about $757, but he's selling it in a store for $12.50. That's the way it works. And that's how it works when you have function composition, thinking about some prices, some discounts, and some costs. All right, you'll get a chance to do one of those in a little practice activity tomorrow. For tonight, we want you to do the homework that goes with day 2. So flip over a couple pages. You got your day 2 homework and the rest of the pamphlet. This is also part of the day 2 homework. Some of these interesting problems. You guys are going to be doing like a triple composition. That looks fun. And then we have some other interesting compositions. You can find mom and you can find ZZ. All right. That's all today, folks.